So this time I'm going to use Desmos to help us fill in our table with all the different braking distances while we vary the speed. So we're going to hold gravity, obviously, friction, and roadway grade constant, and then we'll vary the speed and have Desmos help us create that table. Now, remember, in the table, they give us the speeds in miles per hour, but our formula requires feet per second. So I'll include the dimensional analysis in my calculation for the speed as we go. Okay, so first of all, let's hit the wrench and we'll just get rid of the grid here just to get rid of the distractions. And I'm going to slide my entry column all the way up so that we can put our entries in. I'm going to have a list of variables, so I'll start with a folder called variables, and that way if I need to, I can collapse that folder and get it out of the way. As we mentioned, we want gravity, which we know is our lowercase g, and we're going to use 32.3 feet per second. To freeze this slider so it stays at 32.3, I'm just going to set the boundaries at 32.3 and the step at 0. And then when I hit enter on this, you'll see that it freezes that slider. And so 32.3 is going to stay constant. Our next variable is friction. We're going to keep that one constant as well. And we'll use 0.8 as our value. So I will freeze those boundaries at 0.8 and step of 0, oops, and a step of 0. And now I have friction entered. And then our roadway grade, which is capital G, we'll make that 0.05 and we'll keep that constant also. So I'm going to freeze those endpoints at 0.05. And that way the slider will stay constant. Now, because our data is given in miles per hour, I'm going to include a calculation that will convert those values to feet per second before we use them in the formula. And I'm going to do that here in my variable section. We could also do it in the formula itself, but I think it just is a little cleaner if we do it this way. So I'm going to define V naught, V sub 0, rather than as a straight up variable. I'm going to define that as a function. And this function is going to take the miles per hour, which I'll call variable M for miles per hour. It'll take that value and convert it to feet per second. So our V sub 0 variable will end up being in feet per second. But I have to define it like a function because I'm going to do a calculation in here after receiving the miles per hour. So I've showed you this before in class, but basically the dimensional analysis is that we're going to take our miles per hour. So we'll do miles over 1 hour, and our miles are stored in variable m. So I make a fraction here, and I'm going to put m on the top for the number of miles, and the number of hours I'll put on the bottom here. Then I have to convert the miles into feet. So the conversion factor there is 5,280 feet for 1 mile. So my fraction there will be, oops, let's get it over here. Nope. It's giving me the business. Okay. Let's do 5,280 over 1. Oh my goodness, why is it messed up like that? Oh, because I put it in the wrong place. Sorry. 5,280, I've got it right this time. Over 1. You got to be careful how those fractions, where your cursor is when you're doing the fractions. So it's number of miles to 1 hour times 5,280 feet per 1 mile. So now my miles are canceled out. And then I have to convert hours to seconds. I'm just going to do that in one calculation. 1 hour, oh goodness, I did it again, didn't I? 1 hour happens to be 3,600 seconds. We've used that before. It's just 60 times 60, right? 60 minutes and 60 seconds. And so this dimensional analysis will turn a miles per hour measurement into a feet per second measurement, and that's what we want. So there's no value there. It's actually a formula that'll convert our miles for us. So those are going to be all my variables. I'm just going to close that up for a minute. And now I'm going to go to my actual formula. So we're just using that distance formula, the braking distance formula that we've been using in class. The difference here is that our braking distance is going to depend on how fast we're going. So it's going to be a function of our velocity. So when you enter that, you use letter D, and then you say it's going to depend on velocity. So you say D of, with parentheses, don't write the word of, D of capital V sub 0, because that's our variable that we're storing it in. And then close your parentheses, and we'll set that equal to the formula. Remember that that formula is a rational expression. It's a big fraction. So I'm going to hit my division symbol first, and then I'll put the numerator and the denominator in each place. So the velocity variable is v sub 0, and we need to square that. Use the a squared key on your phone to square it, or you can do shift 6 and then a 2 on a regular keyboard. Then down here, remember it's 2 times the gravity. So 2 times lowercase g times the quantity, lowercase f plus capital G. Now you'll notice at the top of my screen, there's all kinds of red and green curves being drawn. To get rid of that, you can just tap the, in the left here, that color black with a curve. You can tap that, that'll take that one away. And then the red one must be in my variables. Yeah, that's my V naught function. Just tap the red and it'll take it away. We don't need the graph for this activity. What we are going to do is we're going to create the data table that's right there on your handout. So I'm going to, in cell 7 here, I'm going to add in with a plus sign a table. And my first column, that's going to be my miles, just like you have there. They're all listed there, those values. We are going to indicate miles with lowercase m and then put a subscript 1 next to it. So M1, you just have to type M and then 1, and it'll put the little 1 there. M1 is going to be our column where we type in the miles that are given in the table. The other columns are going to be calculated. Along the way, as we go into these columns, it's going to try and create a color for the graph. You can just tap the color to get it to go away. And then instead of the Y1, we're going to delete that. And we're going to put in our formula for the distance, which will use our function that we made, D of V naught. Now, in the first column, we are actually just going to compute the speed in feet per second. So we're going to turn the M1 into feet per second. Our formula that we created for that is up here in our V naught function. So we'll use the V naught formula to compute that. And we want it rounded to 2 decimal places. So before I type anything, I'm going to stick the round function in there just to get that out of the way. If you go to funcs and scroll down to the bottom, you'll see round is there. And then the thing that we want to round is the feet per second. The feet per second is stored in our, or calculated using our V naught function. So type V sub 0 and then parentheses, and then what we're going to send it is whatever number's in column M1. So you just tell it to send it M1. And then close the parentheses for the function V naught, but before you close off the rounding parentheses, stick a comma 2 in there, because we want to round it to 2 places. So I have the word round with a parentheses, V naught with another parentheses, M1, and then close the parentheses, comma 2, close the other parentheses. Our next column, we want the distance calculated with 2 decimal places. So again, I'm going to stick my round function in there because I need to round this bad boy off. Scroll down, select round. My distance function is lowercase d, and it's a function that I'm going to send my V naught calculation. So type in capital V sub 0, or V0, you just type V0. And then remember, we have to send the M1 to that velocity function. So I have to put M1 in parentheses. It's kind of confusing here, but we're getting it taken out care of. We'll close the V parentheses. We'll close the D parentheses. But before you close the third parenthesis, put a comma 2 in there to tell it we want 2 decimal places. And then you can close that off. The black color, you can turn off by tapping the black circle. To get to the next column, you'll have to use the little left and right arrow keys below the funcs button. So I'm going to hit the right arrow, and it takes me over to the next column. This looks a lot neater if you can see it on a computer or a tablet, but we can do it on our phone. In this column, we want to round off to the nearest whole number. So I'm going to use the round function again, but I don't have to put comma 2. So it's the same calculation that we typed before, but without the comma 2. So we're going to do D parentheses V0 parentheses M1 parentheses, close all the parentheses, and that's all this one needs because, and I tap the red to get it to go away. That's all this one needs because we're rounding to the whole number. Okay, to the nearest foot here. So now to get back to the first column where the M1 is, you actually have to use the left arrow key. You can't swipe over with your finger. It's kind of unfortunate that that's the case. But anyway, now what we're going to do is just start putting the values in from our table. And of course, I lost my table here, so I got to bring that up real quick. Bear with me here. So miles per hour, feet per second. So we started with 5. So the first entry is a 5, and you'll see that the values just fill in. So if you're going 5 miles per hour, your feet per second is 7.33 feet per second. Your distance that you'll travel is not quite a foot when you hit the brake. So it's 0.98 of a feet, but you'll see it rounds off to 1 foot. And then the next entry is a 10. So I'd go down here under the 5 and I just enter 10. And again, it gives me the feet per second at 14.67. It gives me the rounded braking distance at 3.92 feet. And then it rounds off to 4. So you just continue down the list and you could fill in your table in your handout. I hope this helped. Let me just tap my screen here to get the keyboard to go away, and then I'll show you again what we have for the variables. So we set up our variables in the variable folder. The only one that was a little tricky was that V0 formula that did the dimensional analysis to convert miles per hour to feet per second. So that one was a little frisky. And then we have our braking distance formula down there, D of V0. We are varying the speed. That's why we made it a function of V0. And then we set the table up so that we could fill in the values. Once you get the table filled in, you'll answer the questions that go along with it, and you'll be good to go. Okay, and you know how to find me if you have any questions. But in the meantime, take care.